So matter is anything that has mass and volume. And density is the essential characteristic of all matter because it involves both mass and volume. You now understand that density is the amount of mass a substance contains divided by the entire volume of that substance, and it gives you a unit that you can apply to any sample of any regular, pure, or evenly mixed substance of the same kind in the entire universe. For example, if you know the density of one piece of quartz, you know the density of every piece of quartz, regardless of how big or small the sample of quartz is. There's one more concept, one more thing that we can use our understanding of matter and now our understanding of density to understand, and that is the concept of buoyancy. Now, buoyancy is important to understand because it helps you to understand why liquids and why gases behave the way they do. And liquids and gases are such an important part of our life in the real world. God made us so that we have to be able to breathe gases to survive, and we have to take in a lot of liquids. We're so familiar with these two states of matter that it would be very useful to understand how buoyancy affects these states of matter. Let's get a definition of buoyancy. Buoyancy is very simply the tendency of one substance to float on another, and usually that first substance is a solid, and the second substance is some kind of a fluid. Fluid means it's either liquid or a gas. Now, there's some things you need to understand about buoyancy. First of all, just because buoyancy is acting doesn't mean necessarily that the object is going to float, but it's a tendency to float. It's an upward push that fluids put on objects that are submerged in those fluids. Let's take a look at some examples of things that have that buoyancy force acting on them. First of all, we need a fluid, though, to submerge things in. We'll use water. So this tank is full of water. Water molecules look something like this. Notice that they're pretty well packed together, but they're not super close to one another. Water has a density of 1 gram per centimeter cubed, or 1 gram per milliliter. It's not a very big density, but comparatively for some substances like wood or styrofoam, it actually is a fair density. What if we took another substance and put it in the water, like that nugget of gold we've been talking about? Well, gold's atoms are packed together very tightly, and gold has a density that is very high, 19.3 grams per cubic centimeter. Because gold is more dense than water, when we put that nugget of gold in the water, it's obviously going to sink right down to the bottom. Does that mean that there's no buoyancy affecting gold in water? There actually is. The water is pushing upward on the gold. You see, when the gold atoms go into and in between the water molecules get pushed aside and they try to fall back down and push back together. So they're trying to push the gold up, but they can't quite move it because it's just so dense, so massive compared to the water, and therefore the gold sinks. What about another example of a similar substance? It looks very similar. This is a brass bead. What would happen if we put brass in water? Brass has a density less than half that of gold, 8.5 grams per cubic centimeter. But it's still greater than the density of water. And if something has a bigger density than a fluid that you're putting it in, that object is going to sink in that fluid. So if I put this brass bead in the water, it sinks right to the bottom once again because its density is so great. All right, but what about a substance that has less density than water? Here's a polystyrene or styrofoam cup. You can see the density of polystyrene is much less than that of water, and the reason that is because those long chains of polystyrene molecules make a mess with each other. They go in all directions. They have a ton of air space in between them. The picture that I have of the molecules that make up polystyrene doesn't really do it justice. There is a lot more air pocket space in between those polystyrene chains than what's shown there. So polystyrene doesn't have a very big density at all. What would happen if we put styrofoam or polystyrene into the water when water has a greater density? Its molecules are much more closely packed together. Well, you've all seen styrofoam cups floating on top of water. In nature, this is a big problem because polystyrene doesn't really decompose, so it just floats around in nature, gets broken up into smaller pieces, and usually ends up eventually either at a water treatment plant where it thankfully gets removed from the water, or it could even float down into the oceans where it just floats around and around for a very, very long time. But polystyrene easily floats on top of water because of its really low density compared to the density of water. In the case of polystyrene, the buoyancy force of the water was enough to push the cup in its low density upward enough that it just floats on top. It doesn't even sink in very deep into the water. Now, solids are not the only things that experience this buoyancy force. And it doesn't just happen when things are submerged in liquids either. Sometimes buoyancy acts on things that are in gases, like these balloons in the air. This is a representation of the air outside of the balloon. Notice that the air molecules are really spread apart. Air is made up of a bunch of different things. Here we have some blue nitrogen molecules, some red oxygen molecules. You'll see a black and red carbon dioxide molecule. There's a water molecule. There's even some free helium gas outside in the air. But the air, even though the molecules are really spread apart, is much more tightly pressed together than helium gas would be. So if we trap helium gas inside the balloon, its particles are so spread out from one another that it has much less density than the air around it. Therefore, the buoyancy force of the air being displaced and pushing upward on the balloon is greater than the weight of the helium in the balloon, and it's going to push the helium balloon upward. That's buoyancy. It's a tendency of denser substances to sink in less dense substances, and less dense substances to float on top of denser substances.